welcome everyone to the MagLab Summer Exploration Series, Friday, week 9. I'm your host, Carlos Arvia, and joining us in person, Roxanne Hughes.
Co-host.
She'll be our co-host today. We're praying and hoping for a solid internet connection for the next 20-ish minutes, but who knows what the future has planned for us. So, the weekly poll is up. If anybody's coming in, please go ahead and start that. I want to go over real fast and review the week that we had because we had a very fun week. I will tell you that I didn't realize how much of a connection there was between physics, chemistry, and biology at the lab, and how some of the people in the building that I thought were physicists are doing a lot more chemistry or biology. So there's a lot of learning for me too. So Martha Chacon-Patiño joined us on Monday, talked about ICR, chemistry, and emulsions, and how emulsions actually help us with the cleaning of petroleum, the studying of petroleum, and how we can clean the molecules so that we can make better energy, cleaner energy. A lot there. On Ask Me Anything Wednesday, we had a great talk with David Hike, who successfully defended his prospectus, is on his way to his PhD, but also, more importantly, he is a Ravenclaw. A physicist by trade, doing biology because that's what he likes, but also mentioned that he likes the rats, does not like the mice. Roxanne, the mice tend to bite.
Oh, well, that's
So
good. The rats are adorable. For any of our listeners, like, I know you might think you don't like rats, but they are super cute when I've seen them at the MagLab.
They are cute, they are intelligent, they are really good pets. Mice, on the other hand, not so much. They tend to bite, and that is the hidden lurking danger in the biology lab, as he mentioned. And there was an interview with Ryan Bombeck on Thursday where he talked about one of his students, Lucas, who went to the pawn shop and bought an old shave kit that had some inlaid gold in it. And with a little bit of chemistry, Lucas was able to isolate the gold and get pure gold out of that pawn shop buy. So a really cool thing you can do if you know a little bit of chemistry. So with the review being done, let's see, is our scientist friend in the room? She's not, so we're gonna take this just us. All right, Roxanne, you wanna start the presentation for us? We're gonna go through the emulsions. Somebody mentioned it sounds like I'm saying emotions. So the emulsions challenge.
Do we want to review the poll first, Carlos, in case I can do it. I have the cheat sheet, but
you have the cheat sheet. Let's do that after we do the emulsions.
Okay.
Emulsions.
All right.
Gotta enunciate properly. So first things first, we got this one here using the small quantities of oil, egg, mustard, vinegar. Took the egg and whisked it to break up the yolk, added a spoonful of olive oil to the eggs and mixed it. I can already tell you, I don't think that was enough olive oil. Took the mustard and vinegar, mixed in a separate bowl, slowly added it so it would mix well. I love this last part. Wanted to experiment if the vinegar and mustard would mix since the mustard has some vinegar in it. And they didn't have Dijon mustard, so they just used normal mustard, another variable. Sadly, we have no results listed here. So it doesn't say how well it worked, if it worked at all. So unfortunately, that's all that we have. But I can tell you, I think a spoonful of olive oil, I don't think that's going to be enough. You have to have, I think Martha said 3-to-1 ratio, 3 parts oil to 1 part egg to get a good mayonnaise mix. So let's go on. We got some pictures that we got. All right, started by combining oil, vinegar, Dijon in a small container. Added that to mixture, and this is a nice stainless steel bowl that they've got here. Tried other ways of combining the egg with the materials. Started with just a simple whisk, but the mixture got a lot more thicker when they used the mixing bowl. So this is something that we were talking about pre-show, that if you do it by hand, it is possible, but it's going to be a lot of work. So having that mixture and letting the machine go at it would have given you a great mayonnaise. So they got a half-thick, which is a very scientific term, half-thick, hint of yellow-colored mixture. It smelled like mayonnaise, so not bad, not bad. Next one. Started with 2 eggs, mustard, corn oil, vinegar, lemon juice, and salt. No pictures for the process, and that's okay. We've got a not bad looking mayonnaise in that picture there. Added yolks to it, whisked it together, added some vinegar to the end. Lastly, added some salt, stirred it one last time. Submitter says that they don't eat a lot of mayonnaise, but the sister loves, and she said it was really good. So that sounds like a success to me. All right, simple one here. Looks good, looks a little bubbly, so it might be a little thinner, but they used olive oil, white wine vinegar, 1 egg, shook the mixture, and it emulsified but did not thicken. Very good wording on that. And I hadn't thought about shaking it instead of whisking it, so that's another variable that you guys are throwing in. I'm sorry, I shouldn't say guys. You boys and girls are throwing in. So I love how you're all thinking about variables like that. I wonder if you could take the materials, put it in a bag, and just sit there, shake it long enough if you could get a decent mayonnaise out of that. Just thinking aloud. All right, here we go. This looks like it was done in a what's that machine called?
Food processor?
Thank you, food processor. 1 egg, mustard, oil, lemon juice, mix it for about 2 to 3 hours. Is that right, hours? I wish it was not mayo because it's just that you have to put a lot of time, so I want the other cooking projects. Oh, I remember this, that you didn't enjoy the mayonnaise so much, but you were very excited about other cooking projects. So a lot of chemistry, and let me say this when it comes to science and food. When you're cooking, you don't need so much scientific knowledge or chemistry when you're grilling or cooking or flambeing or any of that. However, when you start to bake, the chemistry becomes very important and the amount of the ingredients becomes very spot on. So a lot more care with the chemical reactions happening when you are baking than when you're just cooking. All right, let's move on.
And yes, 2 to 3 hours of leaving an electrical piece of equipment is way too long.
Yeah, and I hope it was supervised at all times because we want to be safe when we do this. Cool picture there. I see the whisk, I see the bowl, I see the yellowish mix. I noticed while stirring my mixer vigorously, it started to thicken. Fantastic. And of course, the more that it mixes, the thicker it's going to get. All right, let's go on to the next one. And I believe the last two are videos. Roxanne, you want to hit play?
Yes. Oh, with music?
Oh, always.
This is great.
So they had a vinegar, more vinegar on the left, more oil on the right, and the one in the very center was equal parts. Oh, and I see Martha has joined us. Let's get her in here.
So the vinegar settled more quickly.
Hello, I was solving some issues with one of the instruments and got caught, but now everything is fine.
I'm glad everything is fine. That's important. Boys and girls, welcome Martha back. So we got a few more mayonnaises to look at, and the issue seems to be that a lot of them stayed very thin. Martha, is that an issue of the amount of materials or just not whisking it enough?
Is an issue about the proportion of the oil and the other species that we want to emulsify with, such as, for instance, the lemon juice. If it's olive oil and it's ultra pure olive oil, ultra virgin olive oil, that one is a little bit more difficult to get it more thickened, like to get it in emulsifier with a better consistency. So I will suggest increasing the amount of emulsifier that you add. Instead of 1 egg, trying to 2 egg yolks. Also more mustard or some spices. Garlic also has some emulsifiers on it, or for instance, like honey.
These are all variables that I would never have thought of. But actually that goes along with what we've been talking about, because we said one of the mayonnaises that didn't thicken enough, they said that they had used olive oil. So that makes sense. Is there a reason why olive oil doesn't work as well?
Can you repeat that question?
Yeah. What's the problem with the olive oil, or the issue with the olive oil that it doesn't work so well?
Oh, because it has some fatty acids in a higher concentration, such as more omega-3, and omega-3, because of its molecular structure, is more difficult to get into emulsion because it has some double bonds in a particular position that prevent the molecule to orientate, uh, like eventually in an interface for making that thick emulsion.
Great answer. Thank you, Martha. Roxanne, let's go on to the next slide, please. And here we had a full-fledged experiment, which was not edible because we decided to use cleaning products in our mayonnaise. So I'm glad that they did mention, do not eat this. But what they said at the bottom, there's no limit on what you do for the sake of science. And I agree with that, but they made mayonnaise with rubbing alcohol and with soap. Martha, what do you think about that?
Add your cleaning product of choice and mix again. Rubbing alcohol. Yes, because rubbing alcohol is gonna be very polar. So you're gonna need more emulsifier in order to go back to the stable solution. So it's very polar. It's similar than water.
And that's what they said. They said that the alcohol was the thinnest one that they had, so that would make sense. What about the soap?
That's great because a soap is the same principle than the emulsifier. Soap is an emulsifier. So you use an emulsifier that actually you can't eat, but that's a great experience because you learn about the chemistry.
All right, and of course, we didn't eat any of these, so thank you very much for being safe when we did that. And the last slide is my thank you slide. I had to recycle an old graphic that we had, but thanks for coming to the MagLab Cafe, home of the Bitter Play Pizza.
Oh, that's great.
All right, let's shrink this down. Thank you. Roxanne, do we have any questions?
Nope.
Wow. We have the expert here. Somebody's got to have a question for them. And actually, I have a question. First of all, I want to point out that Martha is in the ICR department right now. Which machine's behind you?
Yes, so here I have one of the machines. This is the one, this is the one that I use, that we use at the MagLab for petroleum applications.
And that's the magnet right here. And over on the left, that is the ionizing section.
Yes, so let me unplug this a little bit so you can see actually more. Sorry. So,
oh no, don't apologize. This is awesome.
So this is the whole instrument. We are analyzing right now some molecules. They are naphthenic acids from petroleum. So that's it. And the 21, the huge, amazing 21 is over here. So that's the 21.
And that is a world record ICR magnet.
And over there is Dr. Amy McKenna in
oh, there she is.
High Bay, yes. So she's working right now with user samples.
That is awesome. So Martha, one of the submissions talked about how much they enjoyed it and wanted to do more food science. So I know that you've done work with emulsions, gelification, and spherification. Ooh, spherification. I think I got that out right. Can you tell us about those two?
So gelification. So we use natural polymers from algae or cellulose derivatives in order to make gels. So we can make chocolate spaghetti, we can make spheres of yogurt, we can do different preparations and learn about sugars and proteins. And the same with espherification, but with espherification is to use some ions that we can encounter in nature, such as calcium, potassium, in order to create metal complexes and make like some kind of polymers. So we can create like some membranes and create like fake vinegar, fake, not that one, fake, the egg fish, how do you call them? Caviar, fake caviar. That one, I was meats.
I'm sorry. Everything after chocolate spaghetti was just at bonus, but I want that chocolate spaghetti. Fake caviar sounds delicious
Fake
too.
caviar, yes. So we can make with fruit juices. Is it possible to make it with lemonade, with broccoli water, with veggie water? Is so delicious. Like you won't think about crazy preparations, but we can make that one, those ones, and we can also make like foams
Oh
using also
yes.
emulsification with air.
So it's possible to make like a mayonnaise foam.
Yes, or
These
butter, like olive oil butter. And this is great because we can start encounter options in order to make our meal plans more healthy.
and all this falls under the head of gastronomy. That's the name of the subject, right?
Molecular gastronomy.
Molecular gastronomy. So there you go, all of you future chefs out there. You're going to need some science, and molecular gastronomy is what you all want to do. All right, Martha, will you stay with us so we can go through the polls?
Can you repeat that again? The noise is a little bit.
That's okay. I just want to see if you'll stay with us as we answer the poll questions that the students had.
We
Okay.
have one more. We have one more question. When you crack an egg into soup, why does it disappear sometimes? For example, after my mom cracked 5 eggs, we only found 4.
That's an interesting question. I will have to to think about that one.
I wonder if we had a yolkless egg, maybe.
Yes, it could be that one. There are some that has that has two, can have two. Yes.
Dr. Martha mentioned how creating emulsions is a technique that can be used to clean petroleum compounds. I asked you, what is a emulsion? What is an emulsion? Leading answer from everybody was a stable mixture of 2 or more liquids that would normally separate, and that is the correct answer. The second leading answer was a homogeneous mixture composed of 2 or more substances. That is a solution.
Yes, that is a solution.
A mixture of 2 or more liquids that separate due to density. That's just 2 liquids that are separated because of density. Is there a name for that?
Heterogeneous mixture.
Oh, okay.
Yeah, that's the way we call them in chemistry.
And finally, a mixture when one particles are suspended throughout another substance. That is a colloid. And truth be told, emulsions are a type of colloid, but it's not a suspension. They are actually more dispersed throughout. I see Martha nodding. That's a good sign.
Yes.
The MagLab's FT-ICR facility provides operations for sample analysis that requires the ultra-high resolution and high mass accuracy of FT-ICR. What is ICR? The leading answer, ion cyclotron resonance. That is the correct answer. The next one was ionic compound refraction. I did enjoy making that up. Also, inactive cell response, not something that exists. And iconoscope capacitor resistance sounds fantastic, but I made that up too. The iconoscope is a real scientific instrument. You can check that out on the MagLab website if you're curious what that is, though. Number 3, Alessandro Volta invented the voltaic pile, essentially the first battery. So you all received in your Tuesday links a interactive wet cell battery where 2 rods were in an electrolyte solution. The dry ends are connected with an LED. My question was, what materials are the 2 rods that were in that solution? The leading answer is identical metal conductors, and that is not correct. If you try doing that with identical metal conductors, nothing will happen. If you try doing it with 1 conductor and 1 insulator, nothing will happen. If you do it with 2 rods of the same materials but different sizes, nothing will happen. You need to have 2 different conductors. Copper and zinc are the most popular, and the thing is that you need different materials because they're going to give up ions at a different rate, and that's going to create a voltage drop across the solution, and that's going to drive the electrons and give you the electricity. So if you use the same material, because they are the same material, they're going to give up ions at the same rate, and you're not going to have that voltage drop. The last question, DC magnets at the MagLab can generate massive amounts of heat. To cool them off, we use deionized water. Why do we have to take the ions out? 8 of you answered that the charge would interfere with the operation of the magnet, and that is absolutely correct. Nobody fell for my water travels faster when it's deionized. I thought that was clever, but no one fell for that. Ions create additional heat. That's not true. And charged water does not cool as efficiently as deionized water. That is also not true. So you guys did pretty good on the polls this week. Thank you. Let's see, what do we have next? Any other questions coming, Roxanne?
Nope.
All right, well, let's take a quick preview of week 10. It's our last week. We've got some amazing guests coming in next week. Peter Morton is going to join us on Monday. He has told me that he promises to tell the polar bear story. So I'm looking forward to hear that because I haven't actually heard it before. On Wednesday, we'll have Sydney Niles. She's going to join us for Ask Me Anything. On Thursday, we have a pre-recorded interview with Munir, and it's the first time that a pre-recorded interview started talking about career and became show and tell. He has a number of minerals that he wanted to show, so definitely go and check out show and tell with Munir on Thursday. And if you missed that, we'll have show and tell on Friday because Munir's going to join us to judge the weekly challenge. One hint for everyone. Find the strongest magnet in your house. You're going to need it next week. So find those neodymium magnets, find those powerful magnets. You're going to need it for the challenge next week. I think you're going to really love the challenge next week. Also, if you have a magnifying glass or a microscope around, find where those are, have them ready to go. You're going to not need them, but they'll be great for the weekly challenge. Martha, anything you want to add before we say goodbye?
No, I'm just very excited that you guys are really interested in molecular gastronomy. Perhaps we will have more sessions in the future. It will be great. And ask me any question. If you want to have recipes, if you want to read books, just send me an email. I will write it down in the chat and you can ask me any question, so I will help you.
And if you don't have Martha's email or if you missed it, send it to me. I can send it to her gladly. Roxanne, is the chat box empty?
There are no questions. I won't say it's empty. There are no questions.
Boys and girls, thank you all for joining us. This is where I remind everyone that the National MagLab is funded by the National Science Foundation of the state of Florida, making all taxpayer stakeholders in our science. In return for your investment, we're positively impacting the nation's economy and making crucial discoveries that will lead to the technologies of tomorrow. Check your inbox. The survey should be in there. As always, please take a few minutes to fill out the survey for us. It helps us make this program better for all of you. So before I say goodbye for today, just a reminder to everyone to stay nerdy, stay geeky, stay true to who you are. Be nice to others. Science is an activity for everyone. We'll see everyone Monday.